Okay, this is journal page 382, 16.4. Number 1, anything to the any non-zero number to the 0 power, for instance 29 to the 0 power, equals 1. Number 2, 12 to the negative first power. Remember, a negative power means it's on the wrong side of the fraction bar, so we have to move this to the bottom side of the fraction bar. And we take away that negative. So it's 12 to the first power, which is just 12. We can't leave a numerator open like that, so we just put a 1. Number 3, 10 to the negative fourth times 10 to the negative sixth. Remember, when multiplying the same base, the different exponents, we add their exponents. Negative 4 plus negative 6 equals negative 10. Still on the wrong side of the fraction bar. So down here what do we have here? Equals 10 to the 10th, but it has to go under the fraction bar. So 1 over 10 to the 10th. And 10 to the 10th means we're multiplying 10 by itself 10 times, 10 using 10 as a factor 10 times. So 1 over it's going to have 10 zeros here. 10 to the first power is 10, 10 to the second power is 100, 10 to the third power is 1,000. Every power of 10 is going to put another 0 on there, so 10 zeros. Number 4, 1 over 3 to the negative third times 1 over 3 to the fifth. Now we could just add these exponents and get to the second power. But what I like is when it's the negative third, I'm going to take care of that right now and put that on top. So now I have 3, this all equals 3 to the third times 1 over 3 to the fifth. Multiply across the top and we get 3 to the third on top, 3 to the fifth on bottom. So I have 3 3's on top, 5 3's on the bottom. So when I cancel out what I can cancel out, I'm going to have 2 3's left on the bottom, which is 3 squared, just a 1 on the top, and 3 squared is 9. So the answer there is 1/9. Number 5, 19 x to the negative sixth. Now this whole thing isn't raised to the next negative sixth, only what it's touching right here, the x. So really that's like a multiply sign in there. So the 19 can stay on top here, but that negative sixth power means that x to the sixth power is on bottom. 19 over x to the sixth. Number 6. 14 a to the negative fifth over a to the negative eighth. Well, I've got to do some switching here. The negative fifth, that means these a's go on the bottom, but the negative eighth means these go on top. That's supposed to be an a to the eighth power. Now I've got 8 a's on top, 5 a's on the bottom, so we do subtract these exponents. More of them are on top. So I've got 14, and I still have 3 a's, or a to the third power, on top. Number 7, 3t to the sixth power times 8t to the negative sixth power. And really, remember, these are right next to each other. That means multiply. So this really means 3 times t to the sixth times 8 times t to the negative sixth. Well, 3 times 8, I can do that and get 24. T to the sixth, so these 6 t's go on top. T to the negative 6 means these go on bottom. Oops. Now that I put them down here, it's just a 6 on the bottom. T to the sixth over t to the sixth, these cancel each other out. That would just be 1, so I'm left with just 24. Number 8. 12 s to the negative 1, 4 to the negative second, R3 over S to the second R to the fifth. So let's take care of these negative exponents. I've got a -1 here, which means that S to the first should be on the bottom. I already have 2 S's down here, so that'll give me 3 S's on the bottom, so S to the third on the bottom. 12 can stay on top. 4 to the negative second power means this 4 to the second power should be on the bottom. 4 to the second power. R30, 3 R's on top, 5 R's on bottom, so when these cancel out, I'm left with 2 R's on the bottom here. So R squared. And then the only thing I can do here is that 4 squared would be 16, so I have 12 on top and 16 R squared S to the third power. Just putting my R, S in alphabetical order. Now I can simplify this. 4 goes into 12 3 times, 4 goes into 16 4 times, so I can simplify this to 3, 4, and then these do not get simplified, the variables here, squared S to the third. So 3 over 4R squared S to the third is our final answer there. And that leaves us with number 9. The density of a proton is about whatever this says, super small numbers that we would use in science class, grams per cubic centimeter. Simplify the expression. So 1.64 times 10 to the negative 24 over 3.7 times 10 to the negative 38. Well, negatives here, negatives here. I'm just going to flip those and put them in the right spot. 1.6 stays on top, but this 10 to the negative 38 means it's wrong side, so I'll bring that 10 to the 38 up here. 3.7 stays on the bottom. 10 to the negative 24, I'll bring it down here and make it 10 to the positive 24. Well, now I've got 38 tens on top and 24 on the bottom, which means I have 14 more on top. So when I simplify these, I'll have 1.6 times 10 to the 14th over 3.7. And 1.6 divided by 3.7 would give us, I'll do it down here, 0.4, hold on, this should have been a 1.64. So that'll change things. Sorry, 1.64 up there, 1.64. I dropped it since then. So 1.64 divided by 3.7 would give us approximately 0.443 times 10 to the 14th. And remember, every time I multiply by 10, I'm moving that decimal. So I'm going to move that decimal 14 times. So here's 1 time, 2 times, 3 times, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Put my commas in where they go. And then this would be, what, grams per cubic centimeter. Awesome. Well, boys and girls, have an awesome night. Remember to ask questions in class or come to tutoring if you have any questions, and we'll see you tomorrow.